experience, I can say in chapter 1, there's really two things that sometimes give people trouble. The first is those levels of measurement that we did, the nominal, ordinal, interval ratio, because it's not always clear cut, it's a little bit iffy. The second is what we're starting with today, some of our sampling methods. This one, it's not so much hard to understand, but you might have to refresh your memory, okay? You may have to study these 4 terms just a bit so you know which one is which. That's really all there is to that. So yesterday we talked about the first sampling method. Which one did I touch on? Simple random sampling. So in simple random sampling, what is that?
Each person has the same chance of being selected.
Everyone has the same chance of being selected. So when we all went to the gym and they put every student on the wheel and spun the wheel, did every student in the gym have an equal chance of being selected? Yes, that's simple random sampling. Okay, so the next one is stratified sampling. So in a stratified sample, we break the population into strata. Those are non-overlapping groups. So you can't fit in 2 of them. You're in one group and everybody fits somewhere. And then you obtain a simple random sample from each. So really, when we break them into strata, there's some similarity in everybody in the strata. They have something in common. We did a stratified sampling when we were in the gym on the first day. What was?
The freshmen.
Yeah, for the games. They broke you into strata. Your strata was your class. And then from within the class, we took a simple random sample. Okay, so if it had been a true simple random sample for the games, we would have just used the wheel that had everybody and selected 20 people to come up. But we didn't. We broke you into groups first. That was your strata, your group, and then we took people randomly from within that group. Does that make sense for stratified? Systematic is found by selecting every case individual from the population. So I need 10 volunteers to play a game. So I'm going to stand by the gym door, and every 10th person I'm going to hand them a card. And then when we go in the gym, everybody with a card has to come up and play my game. In a cluster sample, you take everybody within a group. So it would be like you go in the gym and everybody is broken into a group, so freshman, sophomore, junior, senior. But instead of taking a few from each group, I just take an entire group. I spin the wheel and it says freshman, so the entire freshman class comes up. So you're still broken into groups like in Stratify, but then instead of taking some from each group, I just take an entire group. So another example. So let's say I want to see today if people like the lunch options. So if I stand at the cafeteria door and start with the 5th person that comes in, and after that 5th person I ask every 20th person to take a survey, which type of sampling is that? That's systematic. I took every 20th person, so it all depended on what order you came in, and I had that predetermined. All right, what if I said, okay, I am going to randomly select people sitting at each table. So each lunch table I walk up to and I randomly select 5 individuals from every table. Okay, so we have, when I'm talking about every table, they're separating the groups. So it's either stratified or cluster. If I took a few from every one, that would have to be stratified. What if I said I numbered the tables and I picked a number out of the hat and I got number 2, so I went to the second table and I said, everybody here, take my survey. That would be cluster. Right? What if I just took an alphabetical list of every student in the school and used a random number generator to select 50 people? That's simple random sample. Are we okay with these? So let's look at an example. In 2008, the United States Senate had 47 Republicans, 51 Democrats, and 2 independents. The president wants to have a luncheon with 4 Republicans, 4 Democrats, and 1 other. Obtain a stratified sample in order to select members who will attend the luncheon. So let's just kind of talk about this. When I say stratified, what does that mean? They're split into groups. What would my groups be? Okay, and then how do I pick the people in each group?
Give them a number.
Yeah, we need random numbers. All right, let's try it. Grab a calculator. Make sure we remember. All right. So we need to start with a seed. So let's all do the same one. Let's say I did 9. So I pushed 9, and then what do I do? Store, math,
probability 1.
Probability 1. So it's rand. And I hit enter, it comes back 9.
And math, then probability, and then number 5.
Did everybody get your seed in? So then we go back into our math probability. Number 5, random integer. So Republicans, how many do I have?
47.
47. So I do 1, comma, 47. How many do I want to select?
4.
4. Why don't you just hit comma 4? So 1, comma, 47, comma 4. What's wrong with this? It gave me the same number twice, didn't it? It gave me 34 twice. So let's do it a different way. So if we go math, probability, number 5, random integer, and just do 1, comma, 47. Then what does it give me for my first number? 9. And how do I get the next one? Just hit enter. 36, enter, 34, enter, 29. The benefit of this is if it gave me a repeat, I just hit enter again, and I get another number. So I would assume I had probably an alphabetical list of all the senators, and I just picked those people from the list. All right, so for my Democrats, you could change your seed. We don't really have to. So we could just go back into math probability number 5. And this time I need to do 1, comma, what? 51. And I got 8 for my first one. I want 4 of these as well. So then 20, 7, and 28. Okay, for my independents, so back math, probability, random integer, 1, comma, what? 2. There's only 2 of them. And it gives me a 1. So this is an example of stratified sample. They were broken into groups, Republican, Democrat, other, and then I randomly selected some from each group. Everybody okay with that? And using the calculator to get the random numbers? Okay, so a quality control engineer wants to obtain a systematic sample of 25 bottles coming off a filling machine to verify the machine is working properly. design a sampling technique that can be used to obtain a sample of 25 bottles. So I need 25 total bottles. I said I want systematic. What does systematic mean? Every case number. So pick a number, every 5th bottle, okay? And then you have to start somewhere. So you could say starting with your 1st bottle, you could say starting with the 2nd bottle or the 3rd bottle. You just have to say which one you're starting with. So let's just say survey every 5th bottle starting with the 2nd bottle. When do I stop?
When you get to 25.
So here's a question for you. Do you see any issue with our technique here? Okay. We can start and whenever we want, and we can select bottles as often as we want. But I didn't even tell you how many bottles our machine makes in a day, did I? So if my machine puts out 1,000 bottles a day, we're going to collect our sample pretty early on in the day, aren't we? We're going to have our entire sample within the first hour or so. Why might that be a problem? Is it possible that the machine starts out working really well, but then as it gets hot and the day goes on, that it's less accurate? Yeah. So for this strategy to really be good, you really want to know how many you have, and you want to kind of divide it up so that I would be taking bottles out all day long. So we would have to have a better strategy for finding that kth bottle. If we know the entire population, you can take your population, divide by the sample size, and then round down. So for instance, let's say if the machine makes 1,033 bottles a day. Okay, I still wanted a sample of 25, right? So we would do the 1,033 divide by 25. And that gives me 41.32. So that means we would survey every 41st bottle. That would just ensure that I'm selecting bottles all day long and looking at the whole picture and not just a snippet. You might make yourself a note of that. Just divide, and the key there, round down. If you round up, you're going to run out. You'll have, our machine will stop and we'll only have 24 collected. We won't be able to get that 25th, so we have to round down. The next example. School administrator wants to obtain a sample of students in order to conduct a survey. How could this be done using a cluster sample? So just you're just giving me an example. So remember, in a cluster, we break everybody into groups and we take an entire group to survey, or 2 entire groups. whatever the case may be. So give me a scenario. How should I do this?
The people in the classroom.
Okay. Mr. Talton could come around and say, all right, I'm going to ask Mrs. Fuller's and Coach Van's, Mrs. Beckles' classes. So he walks into those 3 classrooms, everybody in there gives an answer. That's a cluster. Now, is there any problem with that?
None of the teachers were there.
Okay. Is it possible that he comes in during my plan period and doesn't get anybody? Sure. Is it possible that maybe how you guys feel might be different versus how the freshmen feel? And so if he's not talking to any freshmen, the survey may not give him good information. So we have all of those things that we're going to start talking about, what makes our data good versus bad. But that would be a perfect example of a cluster. So you can write that down if you want. So asking all students in certain classes. So our strata, or our groups, are the classes, and then we just take certain ones and ask everybody. One other type of sampling is convenience sampling. So convenience sampling is when you just take people that are easy to obtain. I want to know if you liked what you had for lunch every day, so I ask you guys, because you're all sitting here in front of me. I don't have to go find anybody. I don't have to come up with any good strategy to get my data. I just ask you because you're here. I want to know who to put on the ballot for homecoming royalty. So I send an email out, and how do I make my decision? Based on the people that respond, right? Does everybody respond to that?
No.
No. So is this a good method? Not really. Sometimes it's the only option. You know, homecoming royalty, are we going to go up to every single student and say, okay, take this and fill it out? Does it really matter if people don't want to fill it out? No, it's not the end of the world. But if I am trying to get a good survey, then I want to make sure that my sample represents the whole population. You know, if you think about all kinds of radio surveys, they say, call in and give us your opinion. Why is that not good? Who calls in? Or if you go to a doctor's office and afterwards they send you a survey to fill out. When do you fill out that survey? When you're mad at the doctor didn't do what you want? When you went in because you were feeling awful and they said, you have a virus, there's nothing we can do? You filled out the survey and said, this doctor wouldn't help me, I've been sick for 3 weeks and they won't give me any medicine. When they ask on the radio who has an opinion, you call in if you have an opinion, right? Does that opinion reflect everybody? No. So convenience sampling is very, very dangerous. It's one of the easiest ones to do, so it's done a lot, it's cheap. I asked you to come fill it out, but it's not going to give you good data. The truly best options is multi-stage, which is basically just you use a combination. So any big survey, they don't just do one thing to get their sample, they do a combination of methods. I put an example on here, you don't need to write this down. But, so there's Nielsen Media Research randomly selects households and monitors the television programs these households are watching through a people meter. The meter is an electronic box placed on each TV within the household. So people meter measures what program is being watched and who is watching it. If they really want to do this, they are going to select households using a two-stage sampling process. So first, they're going to have to pick, okay, we have the entire country we're worried about, so I need to break this country into strata probably. I'm going to do the Northeast region and the Midwest region and break it up like that. And then I can't just talk to everybody in the Midwest. And even if I just do a random sample, I'm probably not going to get the entire Midwest. So then I might break the Midwest into regions. And then I'm going to talk to the St. Louis area and randomly select groups within this. So you might have strata within strata within strata, and then selecting from within that. I'm not going to get too crazy with this, but basically anytime there's a combination of methods, that's multi-stage. And that's going to give you the truly best data you can get if you use that combination of methods. So, I don't know, did I put this one on your examples handout? There's really nothing for us to write. I'm just putting what they did. So to do this, they started with census data and divided them into geographic regions. Those were city blocks in urban areas, geographic regions in the rural. They broke them into 6,000 groups. Then they sent representatives to each of those 6,000 groups, and they listed all the households within that group. And then they went in and randomly selected the households in each group through a simple random sample. So that's just one example of what a multi-stage technique might look like. Okay. So the last thing that we're going to talk about today is what happens if we don't have good data. So if my sample does not really reflect my whole population, we have bias. There are 3 types of bias that we might encounter. Sampling, non-response, and response. So I think this is under our table. We've got bias, and I have 3 types there. So bias, your definition, is just results of the sample don't represent the population. That's bias. For whatever reason, my sample was different than my population. So we'll talk about these things and then I'm done. So one reason that might happen is sampling bias. So my data wasn't good because of the sample I chose. So that might be because I only asked the people in my class. You guys don't represent the entire high school student body. So it was a bad sample. So no matter what data I get from you, it's not going to be good. So sampling bias is just when the technique favors one part of the population over another, or you could just put sample doesn't represent the population, something along those lines. I have another term up here. You don't need to write this down, but one way this happens is with undercoverage. So when one portion of the population is not represented. Undercoverage, if I just surveyed you guys, I would have undercoverage with the lower classmen. You guys are upperclassmen. You know, if you're doing surveys, it might have something to do with ethnic groups or with like middle class, upper class, lower class. You might be undercoverage, might have undercoverage in one of those groups. So that's sampling bias, if the problem is with the sample we got. Non-response is basically when the individuals who didn't respond have different opinions than those who do. This happens a lot with convenience sampling. I send out a survey after the doctor's visit and I want to know if you liked your doctor or not. Non-response. If I just took my kid in for a checkup, I probably don't take the time to fill that survey out. The people who respond have very strong opinions, but those opinions may not match how everyone feels. So the people who didn't respond would have felt differently. That's non-response. that down. The third type is response. So maybe I had a good sample, and maybe everybody was equally represented. I didn't have to worry about people not responding, but their answers don't reflect how they truly feel. And there's lots of things that could cause that. It could be the person interviewing. You know, if I want to take a survey and I go and I say, Carly, am I a good math teacher? What might be the problem with that?
She feels pressured.
Yeah, you're going to feel pressured. Do you want to be like, no, you are the worst teacher I have ever had. I hate you. No. So you might not tell how you truly feel because of the person that's asking you. Misrepresented. Maybe the person's writing down your answers and they don't write it down how you said it. So they record it wrong. The wording of questions. Okay, are you ever taking a true-false test and it says, you know, I have not, and then the next one I have, and this is not true, and this is true. And do you ever get confused when they start throwing all those things in there? Yeah, so sometimes the question is really long, and by the time you read it, you don't know what it's asking. Or maybe it was just worded weird and you didn't understand it. So it might be just how the question was asked. It might be the order of questions. So, you know, I might ask some leading questions first. Let's see, I'm trying to think of a good example. So, if I think we should have shorter class periods, I might start out, Jasmine, are you tired at the end of the day? Yeah, sure. You know, do you feel like your school day is too long? Yeah, sure. Do you feel like we should shorten the classes? Now, if I had asked different questions before that, if I'd started out with, do you think you need more time to work on your homework in class? If I had asked that question first versus saying, are you tired at the end of class, would that change how people respond to, should we shorten our class periods? Yeah, absolutely. So it might be the questions that were asked before it that changes how someone answers. So there's a lot of things that go into a good survey. And you have to make sure that the answers you're getting really reflect how people feel if you want to ensure that it's good. Okay. I think I said this was the last thing. Can I do one more? Can I do the error bubble? Or error bullet, and then I'll stop. Okay, so we have different kinds of error. You know, we have bias, so we're getting our data and it's not good. This can create error. Basically, we have sampling and non-sampling errors. So non-sampling would be like, you told me yes, but I accidentally wrote down no. Or I'm typing up the answers and I transpose some digits when I do that. So it wasn't with my actual data, it's just how I recorded it. Sampling has to do with how we got it. So the problem was in the actual data. I didn't make a mistake when I wrote it down. It's because of the sample that I chose. I know this kind of feels repetitive with the bias. The bias and error, it's all very closely linked together. So again, I wrote a handout for this